Greetings to Madam Shuhada. My name is Saran Kumar Anlaki Siva Perkasam. My matrix number is 33 DCE 20F 2019. Today we are going to do practical task 2, which is to study the severity of quenching. The objective of this experiment is to study the hardness of medium carbon steel samples and their microstructure under the following conditions. The first condition will be is as received, which means it's not touched in any way, shape or form. The second one is annealed, which means it will be heated and then cooled down. The third one will be normalized. The fourth one will be water quenched. The fifth one will be ice quenched, and the last one will be oil quenched. The apparatus that will be used in today's experiment is 6 medium carbon steel samples, furnace at 910 degrees Celsius, tongs, Rockwell hardness testing equipment, beakers, oil and ice quenching mediums, optical microscope, polishing machine with abrasive belt grinder, abrasive paper, flat glass plate with wooden framework, electrical hot air blower, cotton, needle reagent, and finally Rockwell hardness testing machine. The first step is to obtain 6 identical samples of the medium carbon steel and keep one sample aside as the control sample, which means the control sample will be the original one, will be the constant same thing only. We must use the same type of medium carbon steel because that will play a factor if it's different. The second step is to austenize all 5 samples for 30 minutes at 910 degrees Celsius. We have to on the machine, increase it to 910, open the machine, open the furnace, and then put one by one inside. Okay, then we close it. We have to wait for 30 minutes. Okay, then we off the machine. After that, we have to remove the samples from the furnace and quench them in different mediums, as stated before this. The next one will be water. The next one will be brine. This one will be left at room temperature, and then this one will be left to cool down until 400 degrees Celsius. As you can see, the temperature is decreasing. To take note, once all the samples are cooled to room temperature, each sample is polished and the microstructure is observed under a microscope as shown as the following steps. Why is the sample ostensized for 30 minutes? It's because it must be uniformly ostensized, because it plays an important parameter in this whole experiment. The fourth step is just to make sure that the specimen has a flat surface, so we do it by using the belt grinder to make it a flat surface. The next step is to support a polished paper of 1/10 fineness on a flat glass plate. Polish the specimens rubbing in the forward direction only, which means you'll rub forward. To take note, move to the next finer paper, which is 2/10 and 2/0 and 3/0 once the scratches on the specimens are uniform. While changing from one paper to another, the specimens and your hands should be clean, free from abrasive of the previous paper, and the specimen turn through 90 degrees so that the scratches from the previous paper are at right angles to the scratches from the next paper, so that the direction don't be far off together. The sixth step is to finish polishing the specimens on 4/10 abrasive paper, then wash your hands and the specimens. The seventh step is to do the fine polishing on the disc polishing unit. This is just to polish the specimen. We on the machine. This will make it polished, and we can off it. To take note, after fine polishing, clean off the polished surface of the specimen with water and dry it with an electric hot air blower. The eighth step is to etch the specimens with 2% of needle reagent by swabbing for a few seconds. Wash and dry them next. The needle reagent is actually an oxidizing agent solution composed of aqueous nitric acid and ethanol. Then we have to open it, and then swab the specimen with it. The whole reason that we have to swab the specimen with it is to dissolve away a number of its mineral contents, so that we can look at the specimen under the microscope more clearly. As I said before this, the next step is to examine the specimens under the microscope and observe the structural features. As you can see, this is the 100% zoomed for each medium. We can see for the 500% also zoomed. Okay, the question is, which medium gives the most severe quench? As we can see, the ice is the most severe quenched. Okay, we go to the next one. The 10th step is, after noting the microstructure features of the sample, perform the Rockwell hardness test using the cone indicator for all 6 examples, the initial control and everything else. The hand wheel is turned until the specimen is in contact with the indicator, and the pointer of the smaller dial gauge reaches the red dot, so that the minor load of 10 kg is implied. The minor load of 10 kg is applied, as we can see. The 12th step is to see the major load is in set and the motor is switched on. The lever hand is kept in position for 15 seconds. The reading is noted using the C scale. As you can see, the scale is here. We can note it later. We must on it first. Then we have to rotate it to see the. Then we have to off. Then for the next one, as we can see, the values are noted for all 6 specimens. This is the original 6. We can see the total load is will be the same. The scale used everything will be same. Only the Rockwell hardness number will be different, as we tested just now. the ice quenched will be the highest, 60. The higher the Rockwell hardness number, the more stronger it is. The observation is to observe and relate the microstructure feature and the obtained Rockwell hardness number. This will be the annealed. This is the normalized. This is the ice quenched, oil quenched, and water quenched. As you can see, the ice quenched is the highest. The untouched one, the as received, is the lowest. The hardness values obtained can be correlated with the microstructure observation. The higher fractions of martensite are observed in better quenched, thereby resulting in higher hardness value. That's all. Thank you, madam.